Hello, everyone. Welcome to our talk on transforming Facebook finance operations with AI. There are three of us presenting today: Julie Drew, Paul Brandenburg, and myself, David Chi. In terms of the structure of the talk, Paul will start us off with an overview of the order-to-cash process at Facebook. There are many components to the process. This presentation will focus on three areas where we have leveraged artificial intelligence: credit, collections, and cash application. After the overview, I'll discuss our use of AI in credit. Paul will come back and talk about using AI in collections. Finally, Julie will review automating cash application. Let's get started.
Thanks, David. Facebook's mission is to give people the power to build community and bring the world closer together. Over 3 billion people use one or more Facebook apps to stay connected with each other each month. Each day, over 100 billion messages are shared using one of our services. And for those on the line who remember SMS, peak SMS volume in 2011 was only 20 billion messages a day. So we're currently running at 5 times that already. Over $5 billion has been donated through Facebook. And a little known but useful fact for folks who work with charities is that Facebook covers payment processing fees for funds raised on Facebook, the only platform I know of that does that. Want to go to the next slide, David? One of our principles at Facebook is to serve everyone. We work to make technology accessible to everyone, and our business model is ads, so our services can be free. We've been extremely fortunate to have had great commercial success with the ads business model. As you can see on the graph here, revenue grew from $150 million in 2007 to almost $86 billion last year. Want to go to the next slide? So today we're going to focus on our customers who pay invoices we issue each month on standard net 30 terms. These are our higher spending customers for whom it's generally not feasible to pay using a credit or debit card. We sometimes use dance as a metaphor to describe how monthly invoicing works. It begins with an advertiser applying to be billed by monthly invoice, and this happens in the advertiser's Facebook Business Manager account. The dance for our teams will always be between maintaining enough credit for the customer to spend, but ensuring that they continue to pay what they owe us. We support the customer spending, but need to minimize the risk to Facebook. Especially around peak periods, customers can increase their buying rapidly, and so we need to be able to respond with credit decisions quickly to avoid disruption. This is the first area we have leveraged AI. After the spend has happened and we generate invoices, we need to ensure the advertiser pays all invoices in full, and we have a team to work with customers who have not paid on time. This team is a scarce resource, and we need to ensure we are maximizing their effectiveness as measured by overdue invoice amount they bring in. This is the second area where we have leveraged AI. Finally, we receive payment, and this is typically by bank transfer with remittance details in the form of unstructured text, which we need to parse to be able to correctly apply to the corresponding invoices. This is the third area where we have leveraged AI. Back to you, David, if you want to talk about the credit.
Thanks. Before we dive into the actual problems and solutions, I want to note that the AI projects in this presentation were developed jointly between two organizations at Facebook, the Finance Organization and Enterprise Products. Specifically, the applied research team inside Enterprise Products leverages advanced AI and operations research techniques for business applications. We are currently hiring in various locations, so please reach out if you have any interest. All right, so the first use case we're going to discuss is credit. The two primary ways customers pay Facebook is either through a credit card or extended credit provided by Facebook. Credit card process, also known as post-pay or self-service, is what smaller customers tend to use and what an individual just starting out advertising on Facebook would use. Credit card customers get billed as frequently as every day for the ads they run. In this presentation, we're going to focus on the other method, which is extended credit. Extended credit means the customer gets billed once a month and Facebook is lending out the money during that time. Larger customers tend to be on extended credit, the more customer-friendly experience in terms of billing and financing. It's also a win for Facebook because extended credit customers spend more and grow faster. For these reasons, our extended credit customer base is expanding rapidly. This presents both opportunities and challenges. The primary challenge, as Paul discussed in the introduction, is providing enough credit to enable our customers, but being deliberate about the specific credit limit to manage our risk profile. As customers grow their business, their existing credit limits may no longer be enough. Whenever their spending approaches that existing limit, Facebook has to make a decision on whether to increase the limit or keep it where it is. Given the number of customers we have and the number of decisions we have to make, this process has to be automated and has to be accurate. So our solution is create a machine learning model to predict default risk that can be used in the credit decision process. We use hundreds of features in our model. At a high level, these features can be categorized into three broad areas. The first is their history on extended credit, and that's the invoice payment history circle. Second is their other on-platform data. This would include things like their ad quality scores. And third is public financial data that exists from the company. We train our model using bad debt accumulated in the past as our label. Because the features and labels are highly structured, we use a gradient boosted decision tree algorithm. We automatically retrain our model continuously in order to incorporate the latest data. Implementation-wise, we set a threshold to determine which credit requests can be automatically approved and which ones require manual review. The system we developed for credit adjustment is automating thousands of decisions per month for Facebook and unblocking advertising spend for our customers. So the learnings from this project. Using AI to enable Facebook advertisers has taught us a lot about extending credit to a diverse customer base. The main takeaways are that when evaluating our model, while we do use the standard machine learning metrics like precision and recall, we also have to take into account the dollar value of the bad debt. To do that, we use the capture curve shown on the right in the bottom. So this plots the cumulative bad debt against the population of customers sorted by the model score. So in this diagram, the x-axis starts with the riskiest customers. If we identify the risk correctly, then a higher percentage of the bad debt will occur toward the left side of the plot. We will see the capture curve rise rapidly at the beginning. Once we capture all the bad debt, the line flattens over the safe customers that pay their invoices. This is the best metric for us because we use the threshold in our systems, and it's more important to identify the highest value bad debt versus having a high recall if it misses the worst cases. In terms of feature importance, we found that the most useful data is from the customer's history on extended credit. The next most important feature is the other on-platform data that we have for customers. Public financial data is useful for our model and does improve it, but there's a few limitations. One is that it might not exist for companies that are private, so the coverage isn't 100%. The other thing is that the data is trailing. It's published at a yearly or quarterly level, so it's not as fresh as some of our internal data. The last takeaway is the amount of automation that we have enabled. More than half our customers are completely touchless. The bad debt that we do see also does not primarily come from the touchless customers. That wraps it up for credit. Now, Paul will discuss our work in a subsequent stage of the order to cash process, namely collections.
Great. So I know this might come as a bit of a shock to some folks, but not every invoice is paid on time by every customer. So in light of this, we have a collections team to work with customers to secure payment. In a similar vein to credit, we used to apply expert judgment and heuristics to determine which customers to prioritize engaging with. For example, we'd focus on customers with the most overdue invoices or with the longest overdue invoices. The thing to remember here is that unlike credit card payment, where payment's automated, invoice payment is typically manual and customer initiated. Now, this makes sense given an invoice payment could be thousands or even millions of dollars, but it does pose the challenge that there's scope for late payment. I want to go to the next slide, David. So for similar reasons to those David mentioned around our features and labels being highly structured, we employed a gradient boosted decision tree binary classification model here as well. The model scores overdue invoices and assigns a score, which is the probability of that invoice becoming bad debt in the future. We then aggregate these probabilities across the customer's invoices, weight by amount, and then prioritize based on the model identified expected loss. There's two main differentiators here with the credit model that David spoke about. One, here we are scoring at the invoice level rather than the customer level. And two, here we are assessing invoices once they are overdue rather than customers who may or may not have overdue balances. Next slide, David. So our learnings and collections, our most predictive features were perhaps unsurprisingly similar to those observed in the credit model: customer tenure and their payment history. One feature type that was more powerful here was around the customer's ad quality scores, which tended to be more predictive in our collections model than the credit model. This is likely explained by the reduced time window between the prediction and the event being predicted. By the time a customer has overdue balances and has quality score issues, it's more of an issue when they just have quality score issues, and thus perhaps more time to remedy the situation. In applying the collections model to prioritize our collections team's efforts, we observed a 20% reduction in overdue days for accounts prioritized using the model versus a control group using the previous methodology. And now over to Julie to talk about Cash Apps.
Thanks, Paul. So a third area where we use machine learning to support the order to cash process is in applying payments. So every month our advertisers make payments, and at the same time they send us remittance instructions indicating which invoices they want their payments to apply to. And some of our advertisers are paying thousands of invoices at a time, so these instructions can be pretty complex. In the past, most of these remittance instructions were processed manually, which was a very time-consuming process, and also tedious and error-prone. Also, sometimes there'd be a delay between when a payment was made and when it was applied because of the large queue of remittance instructions that had to be processed. These delays are costly for Facebook and detrimental to our customers. An advertiser's spend can be blocked while their payment sits unapplied because they've reached their credit limit. And so this adversely affects the customer experience. Next slide, please. So we built a solution that automatically reads remittance instructions and applies payments accordingly. The solution combines OCR for extracting text and bounding boxes from the document with a template-based approach for understanding the document. So each sender has its own template, and for each template, we create a configuration that describes how to find the relevant information in the document. It's not as simple as using regex to find each field, because for example, there could be many number-like words in a remittance, but not all of them are invoice numbers. So here's an example remittance instruction in the top right figure, where the blue boxes are clues about where to find important information in the document. So in this example, the words total amount or invoice number or amount are names of relevant fields. And in red, we're highlighting the values we want to extract. The key idea behind our approach is to define each field of interest in the document by specifying its name, its value, and then the alignment of the name and the value as illustrated in the figure in the bottom. This template-based approach ensures very high accuracy in extraction. And it's also broadly applicable to processing documents. So we're using it in other areas as well, like reading invoices. Next slide, please. So several learnings came out of this project. First, there's a strong Pareto effect in template coverage, in that a small percentage of senders cover a very large percent of payment dollars. So by implementing just a few templates, we're able to automate a large percentage of cash application. And we found that automating this process significantly reduces the cycle time to apply payments. A benefit of the template-based approach is that it's extremely accurate, but a downside is that remittance formats can change over time for a given sender, and we need to be responsive by modifying the template configuration when that happens. We do have plans to expand this solution. So first, we're building out a UI to facilitate the template creation so a business user could do it. And then the second is a general ML solution that can be used when for remittances that aren't covered by templates. So to conclude, we've shared how Facebook has used, sorry, next slide, please, thanks, has used AI to transform several parts of the order to cash process. In credit management, our model is automating the majority of credit decisions, unblocking spend while maintaining very low bad debt losses. In collections, we're using ML to prioritize collectors' queues and have seen a 20% reduction in time to pay. And finally, in cash application, we're using OCR to automate remittance reading and applying cash. This has significantly reduced cycle time for cash application. We're also working on many new ML applications in finance, such as case management for customer support for our advertisers, and also determining eligibility for monthly invoicing using ML. As David mentioned, our applied research team is growing, so please reach out to us for more information about that. Thanks to everyone for joining the session, and now we'll move over to questions.